Because of the action of the sun, the closer the air is to the equator, the warmer it will get. As it gets warm, it expands and rises, so pressure decreases. When the air molecules reach the tropopause, they are forced to head for the poles, whilst lowering temperature in the process. Near parallel 30 degrees, because of the accumulation and temperature, the air comes down again, compressing, heating, and stacking itself, so generally high pressure forms. As a consequence of the Earth's rotation in the northern hemisphere, the wind will blow clockwise in anticyclones. Due to the accumulation of the air, pressure increases in the center of the anticyclone, so the air particles tend to travel down to low pressure, though they get turning inertia along the isobars. The sea breeze is formed because during the day the Earth's surface tends to get hotter sooner than the sea surface. On a sunny day, this difference in temperature between the two air masses warms up the Earth much more than the ocean, thus generating a small area of low pressure. The air rises as the Earth warms it up, and the cooler air above the sea occupies the space left by the warmer air that has risen above the ground. Therefore, the air masses move because of the difference in pressure, whether on a large scale in the case of atmospheric cells, or on a half scale for anticyclones and storms, or on a small scale for breezes. In meteorology, this horizontal movement is called advection. On our scale, it is perceived as wind. Land breeze is the total opposite phenomenon to sea breeze. At night, the land surface cools faster than the water surface, which maintains its temperature better. The cool flow from the land is forced to fill the space of the warmer flow over the sea, which rises as temperature increases. The land breeze, or katabatic wind, is a wind blowing from land to sea, whereas the sea breeze is a flow from the water to the land. Anticyclones, or high-pressure centers, are found between subtropical regions and the cooler areas of the planet. The Azores anticyclone usually spreads throughout the North Atlantic and focuses on the Canary Islands. It affects the Canary Islands for most of the year, though it withdraws occasionally between autumn and spring. In winter, it is more inconsistent and moves from north to south depending on the position of the Atlantic Depression. At times when there is high pressure all over the ocean, it usually moves to the north of the islands, and the other way round in summer. The high pressure is rarely away for more than a week. When the winter approaches, so does the anticyclone, which may be placed on the islands or close to them. This causes the trade wind regime to decrease and disappear. The intensity of the trade winds varies in relation to the shift of the Azores anticyclone throughout the year. When the distance between the centre of the anticyclone and the Canary Islands is shortened, the pressure gradient usually increases, with the isobars being closer together, so the intensity of the trade winds also increases considerably. In winter, the situation is more changeable more than in summer. The centre of the anticyclone often moves to the north and away from the Canary Islands, thereby leaving the islands to the south of the high pressure. In this case, a wind regime with east to southeast component appears, awakening the action of the trade winds, reducing cloudiness and even dragging suspended dust particles from the Sahara. This is due to the fact that the air mass is less humid because of the African influence and the short distance travelled in contact with the sea. In summer, the anticyclone moves to the northwest of the Canary Islands, in the Azores, generating more intense trade winds. This also lifts up a sea of clouds. It occurs when the anticyclone grows or approaches the island, since the air inside the anticyclones descends or subsides, generating higher temperature caused by increased pressure, thus forming a stable layer where temperature increases with height instead of decreasing, as would be expected. This layer, which ranges between 700 and 1,400 meters, delimits two different air currents. Below it, the cool, humid, lower trade wind controlled by the isobars, and above it, the warm, dry, upper trade wind. This is actually an important and well-known effect in wind fluid dynamics. In a nutshell, it is a particular amount of fluid is forced to pass through a narrow constriction. It will have to accelerate to prevent the total fluid volume from decreasing. When the meteorological wind meets the island of El Hierro, it is compressed between the rising terrain and the inversion layer, with the consequent increase in speed. The wind will escape through its vertices at a higher speed than it was when it was approaching the island. We must be aware of this outflow points. They are easily visible in the sea, delimited by areas with wind blowing in different speeds and different directions. Visible to the naked eye, the borderline between wind and calm, known as cut or shear, limits two distinct areas. One area where the wind moves at high speed offshore, and another sheltered calm area. It is very important to learn how to identify them, because flying too close to the cut wind can be dangerous. The sea is the best indicator, although clouds can also reflect the outflow area through bright spells, roll clouds, broken and scattered clouds. At ground level near the wind cut or wind shear, the breeze usually originates in the opposite direction of the outflow, very often in the completely opposite direction. Flying over this area is very dangerous activity if the pilot is not familiar with the phenomenon. When two air masses coming from opposite directions meet, convergence takes place. This phenomenon produces a local increase in atmospheric pressure, which must be re-established at once, and the only way for the excess wind to go is upwards. So there is general ascent at the meeting point of both air masses. This effect is produced when the opposite air masses bear in significantly opposite wind directions. Otherwise, if they meet a very open angle, a wind shear or wind cut will be originated, and they will meet at a very closed angle. Confluence will start like two adjoining rivers. In all these cases, the rising movement will be weak or even absent. Though convergence may be due to different causes, all of them result in significant ascent of the air masses. When convergence takes place, thermal and dynamic rise is also reinforced. On blue days, the area of high activity will be marked by a well-defined line of cumulus. On cloudier days, cumulus clouds will tend to develop more than the others and will show a darker base.